Hello, thank you very much for joining. This is Leandro Mora, and we are going to talk about columnar databases. This lecture is going to be divided into two, and the first one is going to be about the basis of columnar databases. So now, let's start answering the following question. A columnar database, also known as column-oriented database, is a database management system that stores data in columns rather than in rows as relational DBMSs. The goal of a columnar database is to efficiently write and read data to and from hard disk storage and speed up the time it takes to return a query. Now let's talk about column-oriented storage. Column-oriented storage for database table is an important factor in analytical query performance because it drastically reduces the amount of data that we need to load from disk and reduces the overall disk I/O requirements. Let's see the picture on the right. Oops. On the top, we have a row-based storage, and below we have a column-based storage. Now let's pay attention to the country column. Here we can see that the Italy value is repeated 4 times. In a column-based storage, we can compress that information and store the Italy value only once. It will reduce the amount of data that we need to load from this and the overall disk I/O requirements. Now, let's continue talking about the benefits of using a columnar database. Column-oriented databases are designed to scale out using distributed clusters of low-cost hardware to increase throughput. This makes an ideal scenario for big data and data warehousing. Recall, scale up means that we are going to add more power to our existing server. Scaling out means that we are going to add more nodes to our cluster. Now let's talk about the differences between columnar database and a relational database. And for that, let's see an example. Here we got a relational data model for storing data about employees. As data is inserted into the table, it is assigned an internal ID. The row ID is used internally in the system to refer to data. For the first row, 001 is going to be the ID that the database is going to be using. Row-based systems are designed to efficiently return data for an entire row or record in as few operations as possible. By storing the record's data in a single block on the disk, along with related records, the system can quickly retrieve entire rows with a minimum of disk operations. In column-oriented storage, we got a different scenario. A column-oriented database serializes all of the value of a column together, then the value of the next column, and so on. Column-oriented systems are designed to efficiently return data for a column or record in as few operations as possible. By storing the column's data in a single block on the disk, the system can quickly retrieve results of aggregations with a minimum of disk operations. Now let's analyze both kinds of systems. Row-based systems are designed to efficiently return data for an entire row or record in as few operations as possible. This matches the common use case where the system is attempting to retrieve information about a particular object. For instance, we may retrieve the contact information of an employee in a single disk read. Row-based systems, on the other hand, are not efficient at performing set-wide operations on the whole table. Let's see an example of that scenario. Imagine that we need to find all records in the employee tables with salaries between $4,000 and $5,000. For that operation, the DBMS would have to fully scan through the entire table looking for matching records. Now, let's analyze column-based systems. To start, as two records store the same value, for instance, Jones, it is possible to store this only once in the column store, along with pointers to all of the rows that match it. For many common searches, like find all the people with the last name Jones, the answer may be retrieved in a single operation. Whether or not a column-oriented system will be more efficient in operation that depends heavily on the workload being automated. Operations, on the other hand, that retrieve all the data for a given object are slower. For instance, retrieve the contact information on an employee is going to be a slower operation. In row-based system, the row-based system can retrieve the row in a single disk read, whereas numerous disk operations to collect data from multiple columns are required from a columnar database. Now let's talk a bit about indexes. Row-based storage have a workaround for the problem that we mentioned before, and we think that it's responsible to mention it. To improve the performance of aggregations, most DBMSs support the usage of indexes. The indexes store all the values from a set of columns along with row ID pointer backs into the original table. An index on the salary column could look like this. As they store only single pieces of data rather than entire rows, indexes are generally much smaller than the main table stores. Scanning this smaller set of data reduces the number of disk operations. If the index is heavily used, it can dramatically reduce the time for common operations. However, maintaining indexes adds overhead to the system, especially when new data is written to the database. Now, let's wrap up the first part of this session talking about the main features of a columnar database. The first one is that they are well suited for OLAP workload, because the OLAP workloads typically involve high complex analytical queries over all data. The second feature is that column-oriented databases are designed to scale out. The third feature is compression. There are some opportunities for storage size optimizations available in column-oriented data that are not available in row-oriented data. Columnar compression achieves a reduction in disk space at the expense of efficiency of retrieval. Think about it. The greater adjacent compression achieved, the more difficult random access may become, as data may need to be uncompressed to be read. Therefore, column-oriented architecture are sometimes enriched by additional mechanisms aimed at minimizing the need for access to compressed data. And the fourth feature is the flexible schema. Unlike the traditional defined schemas of relational databases, some column-based NoSQL solutions do not require a pre-structured table to work with the data. Each record comes with one or more columns containing the information, and each column of each record can be different. Now, in the next session, we are going to talk about a practical example, Apache Cassandra.